Let z be the standard normal random variable. Find the conditional probability that z is less than negative 1.36, given that we know z is less than 0.44. So we're interested in the conditional probability. We'll write it down here. Oops. Forgot my z. There it is. Z less than negative 1.36, given that z is less than 0.44. And we'll just quickly double check. Yep, that's what we want. Okay, so it's a conditional probability. So the first thing we might do is write down that conditional probability formula. So it's a ratio of two probabilities, the known events probability, so the thing that we are given, the second thing listed, z less than 0.44. Okay. And then for the numerator, the probability of the intersection of these two events. So z less than negative 1.36 and, intersection, z less than 0.44. Okay. So right away, the denominator here can actually be looked up in our standard table. So we'll go to 4 decimal places, 0.44. Okay. So 0.6700. Right. So that's going to be the denominator, 6700. But what of the numerator? Right? What's this probability here? Well, it's an intersection of comparisons, inequalities, events made with the standard normal z. And, well, we kind of need to figure out a way to calculate this, but this isn't something that can be looked up in our table. We need to do some work first, get some calculations going, and then it will likely reduce down to looking up one or two things with our table. So we've got the denominator. Let's focus just on this numerator event. So let's try and understand z less than negative 1.36 and z less than 0.44. What does that look like? Well, we might realize if z is less than this negative number, z is automatically less than 0.44, right? We can even visualize this on a number line here. So we get 0 here. We got this positive 0.44 over here. And then we've got our negative 1.36. So if we've got a value of z that is less than a negative 1.36, so we're talking about values of z like negative 2, negative 1.47, something like that. These are values on our number line that are over here on the left. Okay? Now, what values for z would satisfy this event, being less than 0.44? Well, that's anything to the left of 0.44. Okay? So the intersection of these two sort of shading in of the number line here is just everything that's over here on the left of negative 1.36. So that really is the intersection. The less than 0.44 doesn't really add anything to it. So we realize that this intersection of two events really is just this much simpler looking event. So we can come back here and revise what's our numerator. Well, simplifying our event, we're just interested in the probability that z is less than negative 1.36. Now that can't immediately be looked up in our standard normal table, but if we draw a couple pictures, we can figure out what to do with it. So I'll draw a bell curve, negative 1.36. The probability that z is less than negative 1.36 is the area to the left under the bell curve here. And so this is what we want. Okay. But when it comes to this table here, well, you can't deal with negative z values. That's not what's given. The smallest value is 0.00, and then it only ever increases. So, get back to our question here. What can we do? Well, we use the symmetry of the bell curve. So the bell curve is symmetric about the y-axis, about this 0 line here. So what we're going to do is we're going to flip everything over. So this negative 1.36 flips over to become positive 1.36. And the area that's shaded on the left over here, it flips over as well and gets shaded on the right. But the area is the same, it's just in a different location. So this is the same as the area to the right, so that's the probability that z is greater than 1.36. But this is a positive. That's good. We need positive z-scores. But, again, the table only tells us so much. The table only allows us to work with areas that are to the left of positive z-scores. So what we're going to do is we're going to take the whole area under the bell curve, which is 1, and we're going to take away the area that we can look up, the area to the left. So the area less, the probability of z is less than 1.36. And that will be the same. You take the full thing, you take away this whole little bit, and you'll be left with just this probability. Okay? So the numerator that we want is the same as this probability here, which is the same as 1 minus this probability that can be looked up in our table. So so I'll have to scroll down a little bit. 1.3, 0, 1, 2, 3, 4, 5, 6. Okay. So the probability is 0.9131. We take that away from 1. 9131. We'll just double check. Yes. Okay. So we can just do this by hand, and you might be able to do it in your head, but 9131. Let's see. 9, 9, 9, 10, 9, 6, 9 minus 1, 8, 9 minus 9, 0. So here's going to be the probability we have for our numerator. So we can go ahead and put that in. So what have we got? The probability that we want in this question is going to be 0.0869, assuming we're working with up to 4 decimals, over 0.6700, I believe. Yeah. Okay. And there we go. I mean, you could leave it like that. I'm going to rewrite these because we are to 4 decimal places. I'm going to rewrite these as fractions over 10,000. You say, well, why did you write it over 10,000? Can't you cancel out the 2 zeros here? Yes, but I'm about to simplify things. All right, how do we divide fractions? We changed our decimals into fractions. How do we divide fractions? You invert and multiply. And so this is why I wrote them with both of them with 10,000s, because now the 10,000s cancel out. And so our probability is approximately 869 out of 6,700. There we go. And we'll leave it like that. So that is the probability. 869 out of 6,700.